In this video, we're gonna cover 3 main ways to use variables in Bash, and we'll give some real-world examples that most new Bash programmers are searching for. These will help you quickly set variables and cut debugging time by examining their values. Hey, it's Neilin here from Stacks Add Up, where I help you learn the technology stacks more efficiently with online video. If you're new here, make sure you click that subscribe button, and if you're seeing value in this video, give me a thumbs up as well. It really makes a huge difference. You can find all the links to everything I mentioned in this video in the description box below. Let's jump into it. Let's first see what we can do on a variable. There are 3 main actions we can operate on. The first one is assigning a value or values onto it. The second is that we can see its content by printing it out. And the last one is to test its value to know whether it meets our expectations or not. I'll show you the current operation syntax in each part, followed by examples, so you can quickly grab key points of that operation. Let's go! When assigning a value onto a variable, we have 3 major tools: directly assign, from command, and from a file. For the most fundamental values like strings or numbers, we can use equal sign directly to accomplish the assignment. But be careful, don't have any spaces around it, or Bash will complain about something like command not found. However, sometimes there are values we cannot simply type out. The reason might be that we don't know their values ahead of time, or their values change from time to time. Very often, their values are from the command line results, so Bash provides 2 tools for that purpose: command substitution and arithmetic expansion. We'll discuss them later. And the last one is a Linux built-in command called read, which we can leverage to get values from a file. Let's see some examples. The first tool is by assigning directly, and it's very straightforward. First, we write down a name such as count, then an equal sign, and its value, say 5. Unlike other programming languages, Bash does not accept spaces around the equal sign, so if you have learned others before, you may need to rewire your muscle memory. You can also put strings into a variable like this. And even more, you can chain a variable with another. See, we can put a virgin into the path variable. Now it becomes release/1.0. The second tool is by saving the result from commands. It has 2 types. The first one is called command substitution, which can allow us to save command outputs into a variable. All you have to do is to put the commands into this form: $open parentheses, command, and close parentheses. Take ls as an example. We can list files and save those file names to the files variable. Then see what it looks like. Good! Now we have an update list every time we run this script. Next, let's say we also want to know the number of files. So we pipe the ls result to the wc utility to count. And use command substitution again. Now the file number variable keeps the number. Now you can try with your commands. The second one is called arithmetic expansion, which allows us to do some math and save the computation result. Its syntax is like $, 2 parentheses, some math, and 2 right parentheses. This time, we take a look at the date program. When you just type date on the command line, it'll print out the current time and date. We can change its output by giving a format string. Here we type date plus %s, and we'll see a large number. It's the seconds that have elapsed since 1970 January 1st UTC time. And we save that number into the now variable. The thing we want to do here is to set a 60 seconds timeout by the time we've just got. So we have a timeout variable whose value is 60. And we have a stop time, then the expansion syntax. In there, we put the equation none plus timeout. And let's see the result. Yes, it's just 60 seconds later from the start time. So now we can have a handy script like this. Using a while loop to check whether the time is up, we can ensure our retrying block will not exceed a certain amount of time. The last tool for doing an assignment is reading the data from a file. Here we're using the built-in program read. I prepared the file that contains a few score records. One column is for names and the other is for their scores. Now we head back to the read program. When we use the program, we can assign values from standard input like this. And then we type in the data. Then these two variables receive their values respectively. Another way is to feed the data from a file like this. Then we get the same result. The only difference is that the file has 3 records, though our code above can only consume the first one, so we need a loop to go through each of them. We rewrite the script with a while loop whose condition is the read command. The loop will continue as long as there's a record for the read program. We print a message with those two variables in a while loop body to see whether we read the data right. And at the end of the loop, we use the redirect feature to feed the file content to the loop. Then we run the script. It shows 3 messages with names and scores. Excellent. So these are the 3 major ways to do the assignment. The next step is to print the variable's contents. After assigning values to variables, how do we know their current values, especially when we are not assigning them directly? Well, we can print them out. There are some common types we can print: strings, numbers, and arrays. For most situations, I recommend using double quotes to print because sometimes you might get surprising outputs if you don't. Assume we define a variable file ext with a text file extension start.txt and we want to print it out. However, if the current directory has some text files, what will happen? Let's try it out. When we echo it with double quotes, it shows the string start.txt without any problem. But when we omit the quotes, oops, it shows every text file on the screen. This is definitely not what we want. The reason why this happened is that Bash performed several expansions before running our commands, and there are lots of them. So it's better to always use double quotes with variables unless you just want those expansions in some cases. Syntax number 2, use braces to deal with confusing situations. Say we have here a variable n equals 5, and we want to print a message to say we are going to show the number 5 record. If we type $nth record directly, we will just get a space and a record string. This is because we don't have a variable named nth. Adding braces can help. This time we wrap the variable n with braces and run again. It shows us what we expected. Syntax number 3. Use subscripts to print array elements. There are two cases. If you just want to print a single element, you should use index numbers like 0, 1, 2, etc., while using @ or star for all of them. Say we have an array that holds a few IPs, and if we use index 0, we'll get the first IP, index 1 for the second, and so on. Oh, and in the array case, you should always put braces around your variables, or Bash could not find variables named hosts 0, hosts 1, etc. And if you want to print every element in that array, here we use @ as subscript. Then Bash will bring them all out. Here we are at the final action we can take on variables. Testing. Printing can help us know the value of variables, though it's using our eyes to check, only suitable for debugging. What would happen if we could not stop our script when its values were not in a good state? Mostly that would end with lots of bugs and endless debugging time. That's why we need testing. Here are the common types of testing we can perform. To test whether it's an empty string or not, equal to something or not, has been set, and matches the given pattern or not. Let's have a look at them one by one. The first one we're going to see is emptiness testing. There are two operators for this purpose, -z and -n. Say we want the user to input their name. Here we use the read program again with a prompt, but sometimes the user might hit the enter key too fast, so we just got an empty name. So we can write an if statement to prevent this error. For example, using -z can tell us whether the given string is empty or not. If it's true, we can then inform the user and exit. If that code passes the test, our script can go on without issues. Another example, say we want to know whether there are any error logs after running some tasks or executions. So we use the find program to find them out. And using -n in the if statement, we can know if there are any characters in the errors variable. If yes, there must be at least one error file in the current directory. If the answer is no, then everything is just fine. Now let's see the second one, equality testing. There are two operators here, $! and an exclamation mark and one equal sign. Assume we're writing a for loop to do some complex computations, and sometimes we need to know what's happening inside. So we start writing a for loop to loop through 1 to 5. And we check a variable named debug with a $! If its value is true, we print the current index out for debugging. And we put its initialization here as false. So the default behavior is to run the script silently until we turn it on as true. We can make this script more flexible by accepting an extra argument. So we have another if statement here to check whether the number of arguments is not equal to 0, which means the user has input something. Then we can turn on or off on demand. Next comes the third one, existence testing. There's only one operator for this, -v. Sometimes the behavior of a script will change a little bit depending on some variables are set or not. For example, we usually run operations on the primary server most of the time, and we may switch to the secondary when the primary one is down. However, this is just optional, only when the secondary is set. Let's implement this logic. We first print out the hosts we are going to try. The first one is the primary server. Then we use an if statement to check whether the secondary variable is set. If yes, we will then also print it out. And in the next section, assume we have tried on the primary and got failed results. Then we make a two conditions if statement. The first condition is to see if the test result is failed. The other is to see whether the secondary variable is set. If these two conditions are true, we tend to run the same operations on the secondary server. Now let's execute the script. When we only export the primary variable and call our script, it will only show its content and a failed message without retry. But when we export the secondary variable and call again, this time two servers are shown and tend to try on the secondary one. Finally, we're at the last one, pattern matching. Sometimes doing an emptiness and equality test is not enough. We just need a more powerful tool to check whether a variable matches a specific pattern. This kind of tool is called regular expression in the Unix world. It's actually not a program, but many programs are implemented based on it, such as sed, awk, grep, etc. Bash also involves it as one of its features. So here we're going to write a script to accept input from the user and verify it's a valid number using regular expression. First, we assign the first argument to the num variable. And then we define a regular expression pattern like this. It basically means we only accept numbers from 0 to 9 and can have many digits. Then we use a special operator, an equal sign, and a tilde symbol to match the num variable. If the given string does not match our number pattern, we'll print an error message and exit. Let's run our script. No matter we give the strings like A123 or 456 with punctuations, it will say not a number because there are alphabets or symbols in them. So only each of the characters is a number can pass the test. So we can prevent errors right at the point when it gets wrong. So let's review what we have learned today. What kind of actions can we do on a variable? There are three of them: assign, print, and test. We can use the equal sign to assign values directly for the assigning part, but be careful not to add spaces around it. Another way is by invoking commands, either by command substitution or arithmetic expansion. And the last way to assign is using the built-in command read to retrieve contents from files. Then comes the printing part. The strings, numbers, and arrays are the most common types we can print. And in most situations, I recommend using double quotes when printing their contents. And sometimes you may need braces when variable names cause confusion. For array elements, use number subscript like 0, 1, 2, etc. to access a single element while using a symbol or star symbol for all of them. The last part is the testing. We can test a variable to see if it's empty or not, equal to something or not, is set or not, and matches a given pattern or not. We've also seen examples for each of them. So we now know when to use which to achieve our tasks. All the example files shown above can be found on my GitHub repository. You can find the link in the description box below. Hope these can help you set your variables more efficiently and have less time on debugging. Do you feel that you got a lot of value out of this video? If so, what did you get out of it? Please leave a comment below and let me know what you think. Now, if you're interested in checking out more tips as well, then I put together a PDF guide that is linked in the description box below. This runs through the most common questions that can help you save time on debugging and spend more time creating values. Make sure you're grabbing your free copy of my guide, and I'll see you in the next video. Happy stacking!